This is Chapter 3, Section 4, the first video. Alright, so we're going to do contingency tables, otherwise known as two-way tables and a couple other names, but those are the common ones. So first thing you want to do in a two-way table, a contingency table, is figure out your margin totals, right? So if I add up this way, top to bottom, I'm going to get, what, 70, right? Oop, come on, pen. There we go, 70 there, right? Add those up, I'm going to get 685, right? Okay, add those up, I get 305. Add those up, I get 450, right? And then add all of these up, which is my grand total. That'd be what, 755, right? So that's my grand total, right? Grand total. Okay. Also, this and this adds up to that too. You know what I'm saying? So each margin adds up to it essentially. Okay. Let me type those in. Boom. Okay. So these are my marginal sums, right? And these are my joints sums. Okay. So let's try a few out here. So the driver is a cell phone user. So we'll do the probability of user. Right? That is a single event, user. So whenever you have a single event, that's going to be a marginal number. So user is 305. So it's 305 out of the total, which is 755, or the grand total, right? So anytime you are a single probability that's being asked, it is a marginal probability because it's in the margin, which is where we get the answer, correct? Okay. Let's say we want no violations. Okay, so probability of violations, right? No violations, correct? So no violations, 685, right? So 685 out of the 755, right? Using the grand total. Again, this is a marginal probability. It's asking a single thing, so that's the marginal total essentially. Okay. Alright, so let's get into some compound ones here. So this one's asking for the probability of no violations, right? No violations in the last year, and, right, and a user. Alright, so that's what we want. So this is a joint probabilities because it has two things. Because we have violation, right, which is up here, and a user, which is here, right? Oh no, it's no violations. Sorry, no violations. No violations and user. So it's this one right here, right? Because it's joint with these two together. It's joining those two together, right? So it's called a joint probability. So 280 out of the 755, essentially. Okay, so if it's a singleton, it's marginal, which is these. If it's a combination of two with an and, it's those which are joint probabilities, essentially. Okay. Alright, so let's do an OR case. Alright, so a cell phone... let me see if I can get this in the screen here. There we go. So probability is a user, right? User. Okay. Or no violations. So violations not, essentially, right? Okay, so that's a matter of adding up, isn't it now? Because you want the user, okay, which is 305, right, plus the violations, which is 70, and this is out of 755. However, you have to remember, it's an OR scenario. You have to subtract out the overlap. What is the overlap? Okay, I'm sorry, no violations, 685. I said that's wrong. Let's erase that. That's wrong. I am sorry. 685. 685. I just noticed it was no violations, right? So users and no violations, right? But there's an overlap of 280, isn't there? Because I counted two different ways, right? Because I counted these and I counted these, right? To get those two numbers. So I counted 280 twice. That's the overlap, right? So this is the probability of user, this is the probability of no violations, and this is the probability of and, right? Probability of both, right? And. Okay, so if I add these up, I'm going to get, what, 710 out of 755? And clearly these are not mutually exclusive because you can be both at the same time, right? If it was 0, right, you couldn't be both at the same time. Okay, so these are not mutually exclusive event. It's not a mutually exclusive event. Okay. All right. So, what do we want now? Okay, so these are conditional ones then, right? Let me move this up. Let's do it this way so we can actually see the table here. There we go. So these are two at the same time, right? So if we read this, cell phone user given the driver has violations and no violations given that it's a not cell phone user. Okay, so this is the probability of user, right? Given violations, right? And this one is the probability of no violations, right? No violations given not a user. Okay, so at this point we should be able to do the probabilities without actually writing out the formula, right? Because on the top goes both. So user and violations. So user and violations is 25, correct? Right? So that's 25 out of 755, right? And then the condition goes on the bottom, which is violations, right? So violations is 70. It's a marginal probability, right? So that's 70 out of 755, right? Which gives me 25 out of 70. Okay? So no violations and no users. So no violations and no users is 405, right? That's a joint probability. So 405 out of 755. And then the condition of not a user, so not a user is 405, it's a marginal. So 450, what am I saying? So 450 out of 755. So I get 405 out of 450. Okay? All right, so those are both conditional probabilities. All right, so let's type those out and talk about them. So we have this one here, and we have this one here. We get rid of the spaces here. Boom, 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 boom. Okay, so we know that this is an and on top, right? And this is the condition on the bottom, right? So we do the different fractions. User and violations is 25, right? And then this is a marginal, correct? This is a joint on top, right? This is a joint on top. This is a marginal probability on the bottom, correct? So that's a 70 there, right? So I could just skip it and do 25 over 70 if I knew the way it worked, or you can just do it individually with the individual fractions essentially and still get the same answer. Okay, so same thing. Violations and user, right, are 405, and then the users, not users, is this one right here. So that would be your fraction if you just wanted to do the shortcut without actually writing the whole formula. Okay, all right, so let's try another one here. So it may be the case that you don't have all the numbers, right? So view page width. You might not have all the numbers. You got to fill them in, right? So it has to add up to the margin. So 18 plus 16 plus what gives you 45? That'd be what, 11, right? And 11 plus 14 is 25, right? 16 plus what gives me 41? So that's what, 25, right? And then I have to add up this way. So what plus what gives me 55? So that's what, 39. So that leaves me with 16. And then 18 and 16, that's going to be 34. Okay, so there's our numbers that are essentially missing, right? So we should be good there. Okay, so let's do some probabilities now. Okay, so F and C, that's a joint probability, correct? So F and C. So female, right, and coastline, that's 18, correct? It's a joint probability. It's both, right? And it's, of course, out of 100 in this case. That's a joint probability because it's an and. It's both. Okay, so if I multiply these, right, I'm going to be multiplying female, right? This is a marginal and a marginal, isn't it? Correct. So the marginal is 45 for female, and the marginal for coastline is 34. So that's 45 out of 100 times 34 out of 100, right? So that's 1530 out of 10,000. Okay, so that's basically a product of marginal probabilities, isn't it? We're just taking two margins and multiplying them, right? Okay. All right. Are they independent? Well, that is why we did this thing right here, correct? If I multiplied... All right, well, basically what we're saying is, are these equal, right? And the answer is no, because this clearly does not equal that, correct? They are not equal, right? So what this is saying is, yeah, you can multiply these if you want to, but the thing is, there has to seem some dependency in there, which means somehow gender and trip somehow make a difference. So the ones depend on the others, their preferences maybe, I don't know. So essentially, if you look at the math, those two are not equal to each other. So F and C are independent events, right? Okay. All right. The probability of male given the person prefers hiking. What is that one? Okay, let's do that. So the math type here. So the probability of male given they lakes and streams. Okay. So equals. All right. So format color blue. So this is clearly an and on top. Whoops. Probability of male and lakes over the condition of the probability of a lake vacation, right, being chosen. Okay, so we have to go to those, essentially, right? So if we look up here in our table, all right, let's make this a little bit smaller. Male and lake is a joint probability, right? So male and lake is 25 out of 100, correct? And then lake is a marginal probability, right, which is going to be 41 out of 100, right? Okay. So we have a ratio, and a ratio. So the combination was 25 over 100, and the lakes was 41 out of 100. So essentially, whoops, put the equals there. We get 25 out of 41. So the probability of being a male, given you chose a lake vacation, right, is 25 out of 41. So that's a conditional probability, essentially. That's what we just did, right? This one depends on, one is the condition of the other as far as the probability or the event. It's the subpopulation, right? So this is the subpopulation of the thing that already happened, right? So they either chose a lake vacation or that's the subpopulation of the people that chose a lake vacation, right? Of those, what's the probability of being male? Okay, we're going to do the or case. The probability they are female or mountain peaks, right? Okay. So you have to add up. So we need the females plus the hiking, right? So the females were 45, right? And the hiking was 25. And what the question is, what's the overlap, essentially, right? So let's try this. I got to bring it up here. Let's make this a little bit smaller because I don't remember what the overlap was. All right, so the probability of female or the mountain peaks, right? So each of these are marginal, right? Because essentially it's the probability of female, right, plus the probability of, oh, I should have used P, shouldn't I? I don't know. We'll use K. That works better, actually. Let's use K. Probability of female or the K, I guess. Okay, so probability of female plus the probability of the mountain peaks minus the probability of female and mountain peaks, right? So the probability of female is a marginal, so that's 45, right? So 45, and then we said the mountain peaks was 25, right? So the question is, what's the overlap, essentially? Well, the overlap is the 11, right? Because we added up this way, and we added up this way, right? That's not very good. So 11. So we're going to get 59 out of 100, essentially, right? Okay, so that's a marginal one, right? Or I'm sorry, not mutually exclusive, right? So we add up this way, and we add up this way, and we had the overlap of 11, right? So it ends up being 59 over 100, so it's not mutually exclusive events, essentially.